Welcome to Carlton's Math Corner. Today we are going to be solving multiplication and division equations. At this time, will you please make sure that you have your math journal as well as your vocabulary packet. One of our targets today is I can solve multiplication equations using inverse operations. Now here is a picture of a balancing scale. And on one side we have 4, and on the other side we have also 4, but it's represented in a different way. We have 2 pawns here and they represent a secret number. And that secret number is the same for both of those pawns. And your job is to figure out what is that secret number so that both sides of the equation is the same. Or in other terms, if I write this as an algebraic equation, this would be 4. And on this side, it would be 2, let's say these pawns are m's. So I'd have 2 m's. So what I'm trying to figure out is in 2 times something is 4. Or something plus something is 4. And the number would be 2, because I know that 2 times 2 is 4. So my secret number for m is 2. Another way that we could figure this out is if I take the 4, and since there's 2 pawns, I can take 4 divided by 2, and that would actually give me my answer of 2. And this is basically what I'm using as the division property of equality. What I'm doing is I'm taking both sides of the equal sign and I'm dividing both sides by 2 so that I can figure out how much it is per pawn instead of, for one of the pawns. And so 4 divided by 2, the answer is 2. How about this one? If I have 10 on this side and I have, again, 2 pawns, and I'm trying to figure out what is each pawn worth. Okay, if I divide both sides by, since there's 2 of them again, and I'm basically going to use a line to show division. And so if and let me switch those so that there, this line represents divided by, and so divided by 2. And on this side, I would also divide by 2 to keep it balanced. Whatever I do on one side, I'm going to do on the other side. And if I divide that by 2, same thing, 10 divided by 2 is 5. And so each pawn is 5. So let's look at an equation. Let's look at an equation without a balancing beam, and let's look at some that actually have decimals in them instead of just whole numbers. So let's say that, and again, I'm going to actually do kind of what we did in the last videos, is I'm going to use railroad tracks just to separate the left side from the right side. And what I want you to notice is on the right side we have some number times x. And because they're right next to each other, that's why I am saying multiplication. And on the other side we have 9.2. So we're trying to figure out what is this secret number. 0.4 times something is equal to 9.2. If the right side already is 9.2, then I need to make the left side the same amount. And what I'm going to do is I'm going to use the division property of equality. I am going to use the inverse operation, and which is division. And so I'm going to take and I'm going to divide both sides by whatever number is next to x. And if you notice, the number next to x is 0.4. And so that is what I'm going to divide both sides. So if I divide both sides by 0.4, what happens is on the left side, all I have left is x, because the 0.4 divided by 0.4 will just cancel each other out to one whole. And so all I have is 1x is equal to, and now on this side, on the right side, I need to divide this. 9.2 divided by 0.4. Now remember, when we divide by a decimal, we need to move our decimal point one place over to make a whole number. Remember, the second number needs to be a whole number. And so this second number, in order to make it a whole number, I had to move it one place value. And so this one also moved one place value. So really it turned into 92 divided by 4. And so this is what I got. 92 divided by 4 is equal to 23. And so my answer is 23, and I can actually check this. If I plug it in for x, I'm going to actually put parentheses around it just so that I inform myself that I'm plugging it in. I'm taking 23 and it's next to 0.4, so I'm going to multiply. I'm going to take 23 times 0.4 and I get an answer of 9.2. So it does work. Number 2, if I look at this one, 5.4 is equal to 0.3 times r. And so I'm going to do the same thing. Since I'm multiplying, I'm going to do the inverse. I'm going to do the opposite. And so, which is division. So I am going to divide both sides by 0.3. And when I do that, what happens is then on the right side, my 0.3's kind of cancel each other out. But on the left side, I have 5.4 divided by 0.3. And it's the same thing. I notice that the second number is not a whole number, so I got to move the decimal point. I need to move it one place. And so if I move this one once, I need to move this one also once. And so really it turned into 54 divided by 0.3. And this is what I got, and I got an answer of 18. So r is 18. And I can check my answer. I can take r, I can plug it in, put 18 in there, and 18 times 0.3, let's check it out, 18 times 0.3, and I get back to 5.4. So it does work. Let's look at another one. Our next target is I can solve division equations using inverse operations. Well, here I have a balancing scale, and on one side I have 9. On the other side I have a pawn, and it represents a number, and it's some number that's separated into 5 equal parts, and in each one of those parts it is equal to 9. And so here's what it would look like in an algebraic equation. I'd have 9, and it is equal to some number divided by 5. Well, what we're going to use to solve this is we're going to use the multiplication property of equality. What that means is that since I am dividing in this case, what's the opposite of division? Multiply. And so if I multiply both sides, the sides remain equal. And so what I'm going to do is I'm going to actually, instead of dividing by 5, I'm going to actually multiply by 5 on both sides. So I'm going to put times 5 on this side and times 5 on this side. And what happens is these 5s are actually opposites of each other. If I take, any number times 5 and then I divide it by 5, basically they cancel each other out and I get back to where I was before. And so they cancel each other out, but on this side though, I find out that there is an answer to this problem. And this answer on this side is actually what the missing pawn is. So what's 9 times 5? 45. Well, let's put that over here. Does 45 separated into 5 equal parts, would that equal 9 in each of those parts? Yes, it would. And so by using the inverse of division, which is multiplication, we are able to solve this problem. How about this one? Can you figure out what this pawn is? On the left side, we have 7, and on the right side, we have something divided into 6 equal parts is equal to 7. What would that number be? Well, instead of dividing into 6 equal parts, let's do the opposite. Let's do times 6. So what happens is these 6 kind of disappear and all that we have is a pawn, but this is actually the answer for that pawn. 7 times 6 is 42. And so 42 divided into 6 equal parts, each of them is 7, and it works. So let's try out a problem. If I have we'll show the work step by step in just a moment. So let's look at this first one. Some number divided by 3 is equal to 4. Well, the opposite, or the inverse, would be to do what? Yeah, to multiply. And here's how I know what to multiply. I always look for the number that's with the variable. That is the one that I'm going to multiply by the other number. And so if I do that, look what happens. I multiply both sides by 3 to keep it balanced. And the 3's will cancel each other out, so all I have is v. And then what I'm left with, and I'm going to put my railroad tracks just so you can see both sides, what I'm left with is an answer of 12. And remember, you can always check your answer. I can put 12 in, and you should always be checking your answer because you should never get anything wrong with algebra because there's always one answer, and you can always check your solution to see if it works. Is 12 divided by 3 4? Yes, it is. Let's look at another one. I have m divided by 2.6 is equal to 0.8. And so when I am solving this, remember I'm doing the inverse, I'm doing the opposite. And so what happens is I need to multiply both sides by 2.6. And when I do that, remember when you are multiplying decimals, remember you don't need to worry about the actual decimal points. You can get rid of those and kind of just multiply like a normal problem. And so if I do 26 times 8, I would get 208. But I notice that there is one number here. Oops, I meant to actually do a highlighter. One number here and one number here that's behind the decimal. So that's 2 numbers behind the decimal. So I need to actually make sure that I have 2 numbers behind the decimal as well. So my answer is 2.8. And I can actually try this out. I can take my calculator. I can try this out. I can do 2.08 divided by, and because I'm plugging 2.8 in here, divided by 2.6, 2.6. And I get an answer of 0.8. So it does work. Okay, let's do this one. How about if I have 2/3 is equal to 1/6 times W? And notice I'm saying times W because it is right next to the W. And so do you remember in chapter 1 when we were solving equations, and I said, you know, when we have a fraction next to a variable, it does mean multiplication. So the opposite is division. Now, if I take 2/3 and I divide it by 1/6, we got to remember, how do you divide fractions? Oh my gosh, this was a while ago. How many of you said keep, change, switch? Oh, I so hope so, because that is what we got to remember to do. If I divide both sides by 1/6, because that's the one that's next to W, look what happens. I take 2/3 divided by 1/6. 2/3 divided by 1/6. Keep, change, switch. And look what happens. I multiply straight across and I get 12/3. Well, 12/3 is the same as 4 wholes. And I can even put 4 in here. Oops. And I notice that when I do that, I get an answer of 4 times 1 is 4, divided by 6. 4 6 is the same as 2.